and I will also pass on to Heather, who is going to start us off, and John will finish up supporting what Heather talks about. So Heather, I will leave it to you to give yourself a good introduction and get right into your discussion.
Okay, so thank you, John. Appreciate the invite to come and talk to you guys today. As John Alexander said in a write-up about me, I retired about 5 years ago and decided that Linux and that sort of thing that used to be my profession should now become my hobby. So duly joined John Alexander in the Shropshire Linux Users Group, which is the unfortunate acronym of SLUG, as you're probably aware. And when I joined them, they were looking for somebody to do some work on a high altitude balloon project, which they had already nicknamed as the Sheep Worrier for reasons that will become obvious. And I thought this was a great idea. I've always been interested in astrophysics and astronomy, and the idea of getting a camera to the edge of space was an amazingly good idea, I thought. So got heavily involved in that. And some 3-4 years later, we flew this thing. We've now flown it 4 or 5 times and had various bits of success, which hopefully we'll convey to you now. So brief overview, we're going to have a look at the various aspects of the project, which is a lot more than just this balloon. And then we'll take a look at some of the results and the pictures we got. So what is it? Basically, Sheep Worrier itself is the balloon. That's this thing that big latex balloon with a payload, goes up quite a long way, bursts, comes back down again. All the time it's transmitting its location, so once it's on the ground we should know where it is and go and get it. The way we travel around the country finding it is with what we dubbed the sheep dog. There's a picture of my car, I wish, and that's got a radio and a receiver in it, and that can hopefully tell us on the screen where it is. We then had another little project, which was a locator that was based on the ground. This is a bit of Raspberry Pi code, some Android stuff, a tripod with an antenna and some sensors, and we'll talk about that, which was designed to help locate the thing once it's landed on the ground. And finally, we wanted to do something different, so we invented this thing called the Shepherd, which is another balloon, but this one is tethered, so that when the actual balloon has crashed on the ground, we will be able to get line of sight to it by putting up this tethered balloon in the last known location, and hopefully that will then have a line of sight down to wherever the crashed balloon has landed, and it'll be able to relay through LoRa, which we'll talk about a bit in a moment, back to a Wi-Fi and a web page, and then we can see where the coordinates of the crash balloon are. So that's the system. Why did we want to go to the edge of space? Well, really the bottom line is because we can. It's a very cool thing in more ways than one, with a minus 55 degrees C temperature. And we wanted to do some science, which is pretty much what we've got out of it so far. So we'll take a look at the balloon itself, the Sheep Worrier. It's a Raspberry Pi Model A, if anyone can remember that far back, with a thing called the PITS tracker board, Pi in the Sky it stands for. This is basically a GPS connected to a simple radio. To that, we added a few custom sensors. I made a big mistake here. I asked the Linux Users Group community what we should put on it in the way of sensors. And it took me about 2 years to write all the code and get all the sensors working from that came as an outcome of that. But we'll cover some of those sensors in a minute. We also need some thermal insulation because it's going to be very cold and electronics doesn't like running at minus 55 degrees C. custom software for everything, a big balloon, which we'll take a look at in a minute, parachute so that it can come down gently. And one of the first things we tried to do to be innovative was, instead of putting this in a big polystyrene box the way everybody else does, we decided to put it in a Coke bottle and use insulation. So the power from the sun will go through the clear plastic, heat it up inside, and with the Pi generating some of its own heat, hopefully that would be enough to keep the thing warm enough to keep running. So there it is, two Coke bottles heated up, stretched over each other, tied together internally, and a little bit of insulation, polystyrene going on in there, and that's what actually flew. So cheap, cheerful, and quite successful. So what's inside it? Well, it's a 600-gram latex balloon we're lifting it with. 1 meter diameter at sea level. We'll take a picture of that in a minute. But when it pops, it's going to be about 10-meter diameter, so you can see how much it's growing. It's going to be a room-sized balloon by the time it pops. Total payload was about 1.3 kilos, running on 4 AA lithium batteries and a load of nylon cord. And there you can see on the right there, we've got a UV light sensor, ambient light sensors, temperature sensors all over it, battery voltage, GPS. We've got a GPS antenna. We've got 10 degree of freedom board, so it's giving us a magnetometer for 3 degrees, accelerometer, gyro, atmospheric pressure, humidity, temperature, you name it, basically, we've got it on there. We've got 2 radios, an FSK transmitter, and a thing called LoRa, which is becoming quite popular for local networks. Very low power, it starts for long range, and it's pretty good. We thought we'd try that out. I've got a latex allergy, so of course we have to have a latex balloon, which made it rather difficult for me. But basically you buy your balloon based on a whole load of calculations which we did online. And these define basically the ascent rate, and the descent rate defines the parachute. So quite a good collection of stuff there. In order to fill this balloon, we pump helium into it. This was a little system that we devised where the helium goes on the bottom of this pipe here. We fill this bottle with water to get the right lift, and the balloon itself we cable tie onto here. So we fill it and fill it and fill it until this whole thing lifts off the ground. At that point in time, we know that it's at the right amount of helium in it, giving it the right lift to actually go up at our calculated rate. And then we seal off the neck of the balloon. This whole thing gets left on the ground and let go of the balloon, and off it goes. We went for helium. It's a little bit less environmentally friendly than hydrogen, but an awful lot safer. And we thought for our first runs, it was best if we actually did this thing in as safe as way as possible. So maybe in the future we'll go for hydrogen. It's more expensive and obviously more dangerous, but probably the best way to go later on. So there's one of our Linux Users Group SLUG members, Ian, holding the balloon just before we let go of it. It's been filled, as you can see, it's about 1 meter diameter. And yeah, we'll take a little look at how that goes in a little while. In terms of the hardware, we've already talked a bit about the things that we implemented. We went for the newer RPI camera, the version 2.1, which is giving us some nice pictures, 8 megapixel pictures. If anyone's interested, the MPU 9250 is a fairly standard axis, 3-axis gyro. The one I never had heard of until we played with this was the UV light level sensor, and various other things, U-Block 7, GPS and so on. So what it sends is obviously some machine readable information, and we had to define the sentence that it was transmitting, so it just transmits this over and over again. We went for the standard for balloons, which is RTTY, and we'll come on to a little bit why we did that in a minute. But we also put this LoRa system on. They're low power radio transmitters, and they basically transmit roughly the same information. This is the sentence. You've got the call sign that we were using, which is SLUG, the message number, time, latitude and longitude and altitude, a bit about the voltages, some parameters about temperatures, and then a checksum at the end here. Oh, and this is pressure. So that was coming down repeatedly. It's only 50 baud, so it's quite a slow data rate, but it's quite easily received at 10 milliwatts from 40, 50 kilometers. So a useful thing. Software, a lot of it had been done for us. The Pi in the Sky board did all the auto booting, auto restart in case the thing crashed. It also did all the GPS reading and transmitting. But we wanted to do a whole load of new sensors, as we've said. So we built our own LoRa code to drive the LoRa. We built our own camera driver and libraries for all those sensors we just looked at. And we put it all in a Git repo because everything in Linux is done on Git these days. And eventually, it isn't yet, but eventually it will go up onto GitHub. So that was the actual balloon and its payload.
Heather,
Next thing, yes.
got a question on the chat. It says 670 hertz or second separation. Does that mean you're only transmitting every 11 minutes?
No. So it transmits continually. It's 50 bits per second, but the way RTTY works is it's got a it transmits two frequencies, basically one for 0 and the other for 1, and those two frequencies are at 434 megahertz and 434 plus 670 hertz. So it's part of the specification for the RTTY RTTY spec. Hopefully that answers the question.
I believe that does. Thank you.
Okay, well, John will show you a bit of an example, and you'll see something a bit later on about that in operation. So the next thing we did, we'd just done a little presentation within SLUG on designing things with the Eagle CAD board CAD system. So we thought we wanted something to get our teeth into now we'd done that. So we designed up this board. This is basically a radio receiver. This is an antenna. This is a LoRa module, and this is a Wi-Fi and ESP chip. So what this as I mentioned earlier, this thing goes up on a balloon, which is tethered. The radio receiver will receive from the crashed balloon on the ground, which will be transmitting its GPS location up to this tethered balloon, which will then turn it into a Wi-Fi page on this ESP chip, and then we can log on to the Wi-Fi from the ground, and we'll be able to see the messages coming from the balloon, which in turn will tell us where it is. We also designed this so there can be a bit of a generic board, so we can take another antenna here, and we've got some headers so that we can use some of the other features of the ESP chip and the LoRa chip. So generally a good development platform. This is just the computer interface, which obviously is unplugged once it's all programmed up. So what's on this? As we said, it's got the LoRa ESP chip, all programmed through the Arduino IDE. We use this on Windows and on Linux. So again, mostly Linux-based development. The idea, as I said, it receives the signals from a crashed balloon where it has line of sight because it's up in the air, and it relays them down. After we developed this, we started to realize that Eagle, having been bought, I think, by Autodesk, AutoCAD people, wasn't going to be a good solution for an open source groups. So we've now moved everything over to KiCad. So any of the development we're doing now is being done on the open source KiCad, which also runs on Linux, as you're probably aware. So that's what the website looks like. As you can see, I'm logging into it. It's logged onto my my home router there, but this is it. As you can see, this is the message that it's giving us, and we're just extracting some of the information here. So machine readable transmission is being turned into human readable stuff. And this, obviously, you could just type into your GPS and then go to that location. So that was that part of the location system. So part of what we want to do here is we want to run around in the car while it's transmitting so that we can be somewhere near where it's going to land. This is partly as obviously the closer you are to it, the better in terms of receiving it, but also because you really don't want this thing lying around in someone's field or garden for too long, so you want to be reasonably close to it when it comes into the ground. For this, we used a car-mounted radio with cat control. I don't know if people are familiar with that, which is just way the computer can control the radio. Various antennas. I ran mine on Windows 10, but John will tell you about the Linux version that he's got together. We used this program DLFLDigi, which is a FSK translating program, and we had this sheepdog puppy antenna as a backup in case we had problems with our main antennas. So one of the things you probably gathered is that everything we do here is backed up. So there were 2 transmitters, 2 different receivers, and then we had 2 or 3 different people running around below trying to receive this. So here's this DLDigi program in action, and here you can see a little bit of the spectrum that's being received, and it's not very clear from this, but you can see that there are 2 different frequencies in use, and they're 600 and whatever it was, 70 hertz apart. So that's actually the real time. Obviously, this is a waterfall spectrum display. So this is the oldest bit at the bottom. It comes in at the top, and the whole thing just scrolls down, giving you the data. And here's the actual data being turned into human readable form again. So for the first time we tried this, what I was doing was I was reading this from the screen, typing these numbers into Google and asking it to give me directions from my GPS linked PC, and it would then give me directions and tell me where to go. So we'll see in a bit that we could also type this into any normal sat nav, and it would tell us where we're going. When the various trackers received those kinds of signals, one of the features they can do is they can send it back to this central repository, I guess, of tracked information, which is, I think it's a UK site, but it's being run for the world. And it's called habhub.org, as you can see. And basically, anything that appears there is translated into a graph. So you can see that this is our balloon. We started off, we're up here in Shropshire. And on this particular moment, I took a screenshot where our balloon is somewhere around about northwest of London. And these are various people around the world, who well, around in France anyway, Netherlands, who are actually receiving the balloon for us, which is why we used this standard sentence structure that we've just looked at. So these people were receiving it, and because we were using the standard structure, they could use this DLDigi program and relay it back. So even if we lost reception to it, other people around the country and even around Europe, as you can see, could be receiving it and telling us through this where it was. So, and there's not very visible here, but there's a list of 7 or 8 people around the world who are receiving it for us. bear in mind this is 10 milliwatts, so it's a lot less than your average cell phone. Your average CB, for instance, if you remember that, was certainly running in the watts. So yeah, it's very low power, but as long as you've got reasonable line of sight to it, you can get a few 100 miles, as you can see here. In the UK, we need to get the CAA authority to fly this balloon. So obviously we had to do all the licensing, which we called the dog license. And they basically told us when we could fly it and what directions we were allowed to fly it in. They were obviously keen for us to avoid it going over any airspace or any military establishments. So another receiver that we had is this little RTL SDR receiver. John mentioned earlier, I think, that these are $10 devices, and they run really well. We had it connected through a homebrew antenna for one of our guys. Dave was running that. Running SDR Sharp, which is a free piece of freeware that you can connect up, and then piping that through virtual audio cable on the PC, Windows PC, into DLDigi. But again, you can run that through. I think John's using ALSA to pipe it through the Linux stuff that he'll mention later. So here's a view of this SDR Sharp program. Here you can see the two-tone RTTY, but it's so close together it just looks like one tone here. And this is the LoRa, so here you can see the system at a much more zoomed out mode from where we were looking at earlier. And this is just linking the audio through to a virtual audio cable and off to whatever we wanted to look at. So some other things that people wanted to know, that after we ran the first flight, people said, well, what route did you take in the car? We thought that's a good idea. So I wrote a position logger in Qt, so again, multi-platform, based on a very cheap Chinese GPS module, just plugged in, and all it does is it logs continuously every second the GPS location of the GPS sensor, which obviously is in the car, and stores it to a file. And Ian, who we saw a picture of holding the balloon earlier, he wrote some JSON scripts so that we could put all this on a website. And then when we get the live data from the balloon into the PC, we can automatically take it out of that website from the Shepherd that we just looked at, and we can plot it live on a map, so we can have our own local map. I also wrote some spreadsheet stuff so that we can put it all on spreadsheets. And when we get the position plotting data from the balloon, once we've recovered it, obviously it keeps track of everything. We can then plot, obviously, that data, and also anything that's coming in, we can just put it into the Excel sheet. Sorry, say that again. The Excel spreadsheet, and that will actually tell you where the balloon is. And I added a little extra prediction so that if you've got the last 3 or 4 locations and the altitudes, you can then just do a linear prediction to work out where it's going to land. So top right is the GPS logger that we made. That's based on this cheap Chinese sensors, and 12 volts to 5 volts for powering that and all the other USB 5 volt stuff that we wanted, so that we could have a standard 12 volt battery or run it off the car out mobile. So then the sheepdog puppy. So the idea here is this is a custom thing running on a tripod. We'll have a look at it in a minute. So that you can point it somewhere. It'll receive from all sorts of different sources, from the balloon itself, from the Shepherd tethered balloon, or from its own sensors. And from all this information, given it's got its own position sensor and accelerometer, it can work out what angle you're currently pointing the antenna on the tripod, and if it receives the position of the balloon from whatever means, it can then put all that information together and give you some crosshairs on a bit of custom code that we wrote, we'll talk about in a minute, and show you where to point the antenna for receiving the balloon signals. And when it's on the ground, obviously when the antenna is pointing at it, that gives you the direction to walk in. So on the Android tablet, we had a TCP socket set up with a program called Blue NMEA, which is using the Android tablet GPS sensor to tell it where the GPS sensor is. On the Pi, we ran VNC to the tablet so that we could see the display in a nice big graphical form. We then used the custom code on the Raspberry Pi to do the LoRa module stuff direct from the balloon, the link to the Shepherd website so we could get the indirect sensors through it, and custom code to read the accelerometer and magnetometer so that it could know which direction we were pointing the antenna. It was all written in GTK 2.0, which at the time seemed like quite a nice environment to write for the Raspberry Pi. Since then, I think I would have probably gone to the Qt cross-platform in case we wanted to run it on something else. And we also wrote a full NMEA sentence parser for the GPS data. We also wrote some custom LoRa code to run on this device, and we wrote some custom code to do the LoRa proving it out when we were testing the system on the ground. Various interfaces, we've got our own custom I2C interface, SPI, TCP socket stuff, and the NMEA parser that we've already talked about. So there's a picture of what we see on the screen. As you can see across the top, it's giving you information it's getting from the GPS sensor. Next row down is information that it's getting from the LoRa sensor. In this case, it's gone red to tell it it's not actually getting anything from its own LoRa. And at the bottom, it's telling us the ESP data, which it's receiving from the balloon, which tells you where it is. It's telling us that the compass and the inclinometer are both working fine. And then it's telling you what the distance, 79 kilometers, and the bearing, 154 degrees, that you should point at in order to see the, and the altitude to point it at. And I don't know those of you who've seen the film Aliens, but there's a nice bit in there where they've got a little handheld tracker to track where the aliens are. And I thought it'd be quite fun to do something similar, so I created these crosshairs. So as you move the tripod with the antenna on it, you will gradually see these crosshairs move until they go green for the vertical and the horizontal rotation. And once you're over the blue spots, then that means you're pointing straight at the balloon. So then if it's still in the air, you know where to look for it. And if you're on the ground, you know where to walk to try and pick it up. Okay. Also, of course, we needed some parsers so that when we get the data out of the balloon after it's landed, we can parse it all and create useful graphs and stuff. And we also wrote some JavaScript routines to do some very quick parsing of this information so that we can put the stuff online on websites and things if we want to see where it is. So in order to test it, we didn't want to run it and risk losing it. So we had an opportunity to put it on a hot air balloon. And here's the plot of us running it. So you can see we turned it on. We parked the car somewhere here. We turned it on. We walked to this place here where the high altitude balloon, sorry, the hot air balloon, my mistake, was actually on the ground. We walked around here helping out for a while. Eventually they put it on the balloon, and the hot air balloon took off with the payload and flew off over the top of these buildings. So we've taken this thing on the road a few times. We've tracked a few other people's balloons, a couple of things called, one called Barnaby and another called Space Camp. We've done some STEM outreach, science, technology, engineering and maths. Yeah, we wanted to try and make this useful. We wanted to bring the Linux users group to people, and we also wanted to get other people interested in amateur radio and the science and technology behind it. Most people that have seen us at stands find this quite an interesting project, so we think it works quite well. We've been to the Cosford Air Show with the Royal Air Force, and we've also done 2 of the Telford hot air and balloon festivals in Telford 50 and 51, which was 2018 and 2019. During that time, we've tracked it on 3 different hot air balloons, and we've flown it a couple of times for real, which we'll show you. So there we are in a hangar at the Royal Air Force. Big display of the balloon and its transmission. Here's the balloon payload. Here's some pictures. Here's the tracking program that we looked at earlier. And this is the antenna. You can just make it out here in the picture on the tripod that we use for this tracking system that we call the Sheepdog Puppy on the ground. There's the tripod again. Here you can see the display with that little aliens type handheld tracker screen. Here's the balloon and a bit about the outreach. And there's the website that we're receiving on the computer from this tethered balloon, which isn't in the picture, where it's giving the location of everything. This is the Shepherd board that we talked about. This would be on the tethered balloon, and some blank boards and some printouts that we've got of the system and how it all goes together. So one of the first pictures we got from the whole thing when it was up on the high altitude balloon, sorry, keep making them, sorry, on the hot air balloon. So this is taken from the hot air balloon looking down at that place where you saw that it took off on the map. And here's a load of other hot air balloons that are coming up after this one. So that was where we thought finally that we'd got there, that it all was tracking okay and was taking some nice pictures. So we flew the thing for real in July 2019. There it is in pictures. So it's sitting on the table at our local farm. This is where we live. This is the parachute that is connected to it, and it's sitting there taking pictures of the farm. Then we let go of it. You saw Ian holding it earlier. It went up into the air. Here's the parachute on the end of the first bit of nylon cable, and all the way down here off screen down to here. Here's the payload just got off the ground. There's a picture of our farm. Here's the farm building down here. And getting a bit higher, this is a local hill that we've done some testing from. Now we're up quite high, we're getting into the low end of the cloud base. Through the first layer of cloud, the low cloud, higher. Through the second layer of cloud base, this is quite high. Getting higher still. And you can just make out, this is a picture of the moon. Tiny, tiny, tiny little picture of the moon. So at this point, it was pretty high up. It went through the jet stream. And as you can see, this is, I forget how high this is. I'll answer that in a minute. But it's quite a few kilometers up. And I think it was about 25 kilometers at this point. And as you can see, it did some little rotations in the air, high up, and this was all being plotted on that HabHub tracking software. And you can see these green lines are markers to other people who were receiving it. So we certainly knew pretty much where it was at that point in time. It kept going up for a bit, and then it burst, and then it starts coming back down. So this is the point at which, whilst it was doing its little pirouettes earlier, we parked up. And once we knew roughly where it was going to go, we headed off as fast as we could in the car. And as you can see, it's coming down over a town. This is an area called Twickenham over London. And it landed, and we went and got it. We'll show you a little bit about that in a minute. But first, I thought I'd show you a little bit of the data, which shows some quite nice science. This is the atmospheric pressure, which obviously as it goes up and it goes up, and then at some point it bursts and it comes back down again. So the atmospheric pressure, which we could have got out, as you saw in some of those sentences that we were receiving. So we were receiving all of that data. This was actually plotted after we recovered the balloon from the data that it had stored on its SD card. There's atmospheric pressure against altitude, which is quite a nice picture because there's actually two lines here. Obviously it goes down and then it comes back again. So it's pretty reproducible. The atmospheric pressure versus altitude didn't change very much for the journey. Internal temperature versus time. As you can see, we were very successful. The inside temperature of the bottle never went below about 16 degrees centigrade. So we were pretty pleased with that. The external temperature, which was obviously the thing we were trying to protect against, as you can see, it was at minus 52, 53 down here. And for most of its time, it was at minus 35. So our Pepsi bottle solution obviously worked quite well. So we were very pleased with that. Altitude in time, fairly constant rise in altitude. The balloon obviously is providing lift with the helium. Once it bursts, the parachute starts to break it, but of course there's very thin atmosphere, so you can see that the parachute starts to have a bit of a higher impact and slowing the balloon faster at the higher altitudes. So anyway, as I was saying, it was coming down over this place called Twickenham, and you can see that we got some reasonably good messages, and then suddenly it died. But we can deduce from this that it was 308 meters, so it was a third of a kilometer up. And we can also see the path it was taking. And then obviously all the, we broke up because it got down too low. And if you think about it here, it was 300, sorry, over 278 kilometers, sorry, 278 meters up. Then it was at just under 200. So it was probably here around about 100 and something, and we could say that we could linearly interpolate just to work out where it was going to actually land. Here's the plot from that tracking program again, saying where it was heading. And from this, we linearly interpolated, and we reckoned it was going to be somewhere on here, on this road. So I went onto Google Maps. Here's the road, and hopefully Google won't mind me showing this. I used Google Streetview, and there's a picture of roughly what it should be seeing where it landed. And there's actually a picture that we got from it of it having actually landed. So as you can see, our predictions were pretty darn close. We were certainly within a few, well, 20, 30 yards of exactly right. And there it was, the balloon obviously lying, crashed on the ground, taking photos. And there's the next photo it took. Somebody came along on a push bike and picked it up. And you might remember it has a little note in it that's saying, please phone this number and there's a reward if you find it. And so this lovely couple who found it phoned us up. We were heading in the right direction. We were about 2 minutes away from them in the car, so we were pretty close. And they delivered it to us. They wouldn't take any £10 reward we were offering for it. They wouldn't take it from us, but they were very happy that we'd got it back. And yep, so that was a success. So then we thought last year we would fly it again, and we took it up. And one or two pictures for you here. Here's a nice picture with the sun in the photo, which I quite like that picture. There it is coming back down again. We flew this one later in the afternoon. Sun's getting lower. There's the picture it took of where it landed. This time it landed in a field and the sun was just setting, as you can see. And by the time we found it, it was quite dark, and there you can see the eerie glow of the GPS and the Raspberry Pi LEDs on the ground. We picked it up and we took it home. On the way, we went for a nice, well-earned meal and a pint. And I'll leave you with the last picture that we took. Well, one of the last pictures that we took, which is my favourite. You can see a bit of the land there. You can't actually see the curve of the Earth, unfortunately. That's just the spherical aberration of the lens on the Raspberry Pi camera. But it does take a nice picture, I think, and that is where we got at. So I don't know if anybody wants to do questions now, John, or whether John Alexander would like to take over and tell us a little bit about the stuff he's done for the Linux side of the receiving station.
One question we have is roughly how long do the flights last? On average.
Okay, yeah, that's a good question. I'll just whiz back to that one. So you can see that we took it off at about 10:30 in the morning, and it crash landed at about 2:30 in the afternoon. So yeah, so 10, 11, 12, so 2 hours, sorry, 4 hours for that flight. That flight was a bit longer. I think the second flight we did was just over the 2.5 hours. It didn't go as far, but yeah, 4 hours for a long one, 2 hours for a short one.
And I assume just over 24,000. That's the highest you've had before.
This one popped at 24 kilometers. Okay. I think the second one went slightly higher. I think that went to about 28 kilometers. Yeah, so reasonably high up.
Cool. All right. Any other questions? Somebody asked if you were an astrophysicist, and on your bio, yes, you were. So I can answer that.
I've been a lot of things. I spent quite a lot of time writing audio drivers for codecs for cell phones in Linux. So that's why I've got all the Linux and Android background for doing this sort of thing. I worked for Cirrus Logic, Fly the Flag. So we did the all the codecs for the things like Lenovo and Samsung and people like that. So yeah, a lot of that writing drivers and things like that was quite convenient for the writing of the all the drivers we put onto the Pi, the PITS board itself, and onto the Shepherd and Sheepdog Raspberry Pis.
Nice. All right. If there are no other questions, we'll go on to John. Somebody asked, how was the process to get permissions? And this is from somebody who's in the US. So they are in the UK, to the person, Gustavo, they are in the UK. So it's a different process. So for you guys, what was your process? Oh.
Okay, so we wrote to the Civil Aviation Authority in the UK and said we wanted to do this, and they sent us a form to fill in to give us details. And what we actually did was we asked for 4 or 5 possible dates that we could fly the balloon, and they came back and said, yes, you can only fly on one of those 4 or 5, but you're allowed to do it. So obviously, if the weather conditions were going to take the balloon over one of the restricted areas, airports or something like that, then we would obviously have to be abandoning the flight for that day. But luckily, our third date was a beautiful day, and the wind was blowing in exactly the right direction. So on the morning of the flight, we phoned them up and said, "Yep, we're definitely doing it today." They then they'd already got all the notice to airmen. It was called a NOTAM. And that was sent out to anybody likely to be in the area in an aircraft. It spends very, very little time in airspace, but nevertheless, it's obviously something that they want to warn people about. So that's where they gave us the license, and the license says you can only fly on one of these days. You have to notify us, and you have to tell us things like phone numbers, contact details. So if there's anything untoward going on, they can phone us and say, is this your balloon that we're looking at? And we can say yes, and so on. So yeah, so that was the process in the UK. I think it's pretty similar in the US. Obviously haven't done it, but I certainly am aware that you do have to get permission from the aviation authorities over there to do it. But generally, as long as you're conforming, there's things like it has to be under 10 meters in size, which is why we picked a balloon that was exactly the 10 meters size. It has to be connected to the payload with breakable cables, so that if a plane flew through the cable, we just use cheap nylon cord, then it will break, and obviously it won't do any damage to planes or anything else that's going up there.
From takeoff, what is the distances you've had to travel from takeoff to landing? So
right.
how far down launch point does it usually land?
Our first flight, which it stayed in the air a bit longer than we'd intended, it landed about 230 miles from where we took off. The second one was about 170, 180 miles, I think.
Wow. Okay. So you don't want to do it close to the coast?
You do not. In fact, we were a bit worried because it was at one point in time it was predicted to land actually in the sea, but it came down a bit earlier, luckily, and landed at Bristol on the outskirts of London.
Okay. All right. So that is. Oh, how long is the cable? Or why is the cable between the balloon and payload so long? And I would guess that's the equivalent to the weak cable, and that way there's more to break.
Yes, there's that, and also the parachute and the payload itself when the balloon bursts, you don't want the bits, the remnants of the balloon, because they can be quite heavy. You don't want them landing or fouling up with the parachute itself, and also with the longer cables to the parachute, or from the payload to the parachute. It means it's more likely to open and stay as it should do, nicely open and doing the thing a parachute does.
Cool. All right. So one thing I've been asked to say is for all the people on, if you could stay on after John's done talking, and we're going to ask everybody to turn on their cameras so we can take a screenshot for the website. So please hang out for a couple minutes. When John is done, we'll do it as quickly as we can. And with that, I will turn it over to Mr. Alexander. Thank you, Heather, for your time and the information. That was awesome. If you don't mind, can you send either John, or if you have my email, myself, your slides, because we'd like to put those up on the website as well.
Sure. Yep, I'll do that.
Awesome. All right, so Mr. Alexander, on to you, and unmute yourself. Or don't unmute yourself. We don't care, John.
Okay there, yeah, so I've got a couple of screens, and unfortunately it moved over to the other screen. Now, what I've done here is a small video rather than a actual slide, because I wanted to show the actual system being built. So that it does seem to be easy to do with video, and it will actually show the actual virtual machine at the end if people are actually interested. So we can show it all ways round, show it live even. We'll take a risk. All right, and here we go. So as you can see, or have you have seen, all right, we're running around in cars chasing after the balloon, and we have several different setups. Heather was using a dedicated radio for the reception, which is really much better job. But we also wanted to try out different methods, and one of which was just using the quite a famous device now. It's the RTL dongle, which is actually a digital TV receiver. Right, and fortunately we can actually use it as a radio. I think it was actually originally designed in that way so they could actually do software decoding of DAB, which is the prevalent digital radio in the UK and bits of Europe. And anyway, so the units which flew, as I say here, the current system's a 12-year-old laptop, so it wasn't the only laptop, but it was the laptop which worked the best, strangely enough. And yeah, so currently Windows 7, so you can imagine the support is becoming more and more tenuous, right? And now the newer software, which has more features, requires Windows 10, and the laptop doesn't like Windows 10, I would imagine. And so there was a impetus to actually move over to something else, and seeing as it's obviously a Linux outfit and a Linux meeting and a Linux club, then really it should be under Linux if we can. And the idea was that we want to select an installation which could rerun on laptop or Raspberry Pi, or in this case it's actually going to be run on a VM, right? And it's actually going to be used Fedora, but it doesn't really matter much. So we'll just play this on here. Move to the next slide. And here is the actual dongle, right, which is currently in my laptop, and I took a few sample images this morning, very early this morning, and here we go. So we just carry on, and we will actually have an example. So yes, you can actually buy these at that kind of price. So that is that's your radio outfit. So that's $10. So a bit more than $10, but not much more. Here's the actual.
It would be about 12 to 13.
Well, it would be, but I think there's also a few cheaper. So you know, it's a figure, all right. And here is the same electronics which was in the balloon that you saw earlier. So this is the Model A, and that was the smallest at the time we started developing this. And really, you can obviously have a 0 or 0W or one of a million things, but as I say, at the time that was the smallest, and it won't actually change the overall dimensions too much because the actual board with the GPS unit and radios are just here, and that's basically that size. And the top board is the one with the LoRa modules on board, and also I think that's the actual G meter, and over there is also the thermocouple. So and you can see the camera cable flowing off into the distance. And we go to the next one, and this is a picture from my laptop this morning. All right, and it's a Windows solution, as you can tell. All right, this is STR Sharp, not the most modern version of STR Sharp. All right, but obviously working, and the decode is actually in the back window there, so I'm not going to worry about that too much. All right, and but as you can see, but its Fisher Price looks, it is getting a bit long in the tooth. So first, one of the reasons to actually change the overall setup. And if we carry on a bit longer, and it's pretty much saying the same thing. So as I say, it's old hardware, but it works, so that's fair enough. STR Sharp, which is the very common piece of software for most STR implementations, predominantly under Windows. There are a few competitors now, but at the time there certainly wasn't, and it supports several different actual SDR hardware solutions, and it is actually run by, or the designs are literally dealt with. Sorry, the actual software is written by a company which supplies their own solution, so they really would like you to use that, no doubt. So anyway, the FLDigi, which you saw earlier as well, is used to actually decode the balloon, the actual data received, and connected there via virtual audio cable. So I think we've probably seen most of that already with Heather. And as I say, FLDigi is open source, but STR Sharp isn't, I don't think, but it certainly is freeware, so it's not a pay thing for most implementations, but it isn't actually open source. So we'll just go past here. All right, and we'll obviously listen to the received signal. There we go. It's probably gone a bit. Let's go back a bit for you. So yes, there's many implementations. You can have lots of different hardware. All right, and a lot of them are supported directly in STR Sharp actually, but we wanted to try out basically the minimum solution. So you know, it's that $10, $15, £10 type of range. All right, and as Heather's already mentioned that more dedicated hardware was capable of actually receiving from France, Belgium, Holland, and I think some of those were sort of actually beyond Paris. So that's quite a good range, especially considering, as I say, the actual power output is about 10 milliwatts, I believe, so which is about the same as a key fob. So if you imagine unlocking your car from maybe 50 miles away, that's basically what is happening. Obviously, the actual transmitter inside the balloon is 20, I think up to about 27 kilometers, I think it was at one point in height. So you get a lot of benefit from that, but it just shows you what a small signal can actually do. And we're going to play that now. And this is receiving it from maybe 2 feet away. I don't think it's actually going to be too noisy, but if it starts blasting at you. And this sounds like Marvin the chipmunk trying to do a rap, and there's a, and you can actually see the data flowing down there. And as I said, it's not available for Linux, so a Linux solution using STR # probably wasn't going to happen. There doesn't really need to be. There's several other alternative solutions, and we're using GQRX, which is a basic receiver. Right, and good thing about that is actually many distributions already have this as a actual package, so we're not going to be doing any weird and wonderful compiling, and we're not going to have to bring in wonderful drivers and compile everything and make everything work, which is one of the problems with many of the Linux solutions. They, well, although technically superior, will actually take a lot of work. And if you're not new, if you're new to it, then you will obviously just want things to work initially to get that initial enthusiasm, and hopefully become interested enough to do the more complicated and more tenuous things where it doesn't always work straight away. Right, and final instance is obviously how do we actually get these to work together with no sound cards. We obviously can connect cables from the microphone to the actual speaker of your sound card, but that's really not a very good solution, especially on a Raspberry Pi when you don't have a microphone. So we'll go a bit further. And here we go. And yes, a solution does exist, and that is pulse audio. So not so much, well, it is obviously over the top of ALSA, but it's independent in its own right, has its own features, and can be addressable over the network and all sorts of fancy things. But those features we don't need. All right, and we've got a 3-line script, just produce a virtual sync. So that's effectively like a sound card, but with no actual hardware, so it'll just disappear into the ether. And then a monitor plug, as it were, into FLDigi, so it can listen into that. And that's obviously quite handy. We don't have to listen to any of the noise. So I'm going to build this now, not live, but was live this morning, and just go through it. So this demonstrates that you can actually do this. I mean, we've done some USB pass-through. We've got some effectively real-time hardware and software requirements running a VM, which is normally quite tenuous, but just shows that these things will work very well. And because I'm using Fedora, it is actually a Fedora VM, and I've connected RPM Fusion and a few of the basic repos just to make things nice and easy and work first time. So as I say, let's go. All right, so first off, obviously get some root permissions. That's quite nice. And first of all, install the 3 main pieces of software, and that's GQRX, FLDigi, and actually the volume control app for Pulse Audio, and you'll see why in a bit. And this will just trot off and think about it for a little while and install a lot of extras, and that's quite handy, so we don't have to do all this. All right, and it's got the RTL drivers for the actual dongle, which we pass through from the main host, and this will take a few seconds. All right, and this is basically real time. All right, now next thing is that we need to alter the UDEV rules so that your actual user can actually access the hardware. Now, I didn't need to do this on the host because I've got so much of a hardware already in there, so I just created that, and we will need to reboot before we get anywhere, and we'll go a bit further in, and there's a few. Here we go, and this is a little 3-line script which I was going to automate but didn't bother in the end, and that's just purely to create the sync, but rather than typing all that in, I could probably make that into a service later on, but it does need to be run as the user by the looks of things, that you're actually used rather than say root. And there we go. And the next part, and this, because GQX actually doesn't really like Wayland, right, and Wayland is default. I'm just going to change this over, and we'll have Xorg on here, and that works a lot better. There we go. It's as simple as that. And I think there seems to be some gaps between the video, but we'll get the general idea. And we're just going to obviously chmod that little script. And away we go again. I think there's a reboot somewhere just about there. And now we're actually running the actual script. So now we actually have some audio devices. And here we go. So we've already configured in this bit here the RTL dongle, and you can see it receiving. And we've also configured the output device, which is the virtual null output device. And we started FLDigi, and you can see the actual received signal in the little waterfall under FLDigi. And now we're just checking the custom. There we go, 680, close enough to 670, and configuring number of bits. These could all change depending on, it's a fairly standard hardware configuration, but they can change on your particular purchase. And of course, the radio channels do change depending on country or actual unit even. And you will actually see that during this time, the actual balloons, so the actual dongle warming up, and will actually drift slightly. So here we go. I think we've very quickly got the actual output data, and these are the sentences as shown by Heather previously. So we've already done the whole sequence, and that is the extent of your problem. There's no extra bits and pieces required. So you've got the receiver, you've got the decoder, you've got a virtual sound card, or a null output as it calls it, and we're just monitoring that for into FLDigi, and there you go, success. And I'm just letting that run there a little bit, but you can see where most of this is going. It'll just repeat itself with occasional bit of corruption, but there's no aerial on this. The signal is that strong, so there's no. It's a very simple setup. Right, I think this is just going to repeat itself a little bit now, so I'll just stop that there. Right, that is that. So I think we're all ready to questions, actually.
All right.
We can shed a live one if you'd like to see it actually running right now. But you can see it's quite a simple setup. So we wanted to move away from Windows, mainly because obviously Windows was moving away from us and that very old laptop. And what you don't see there is the bit of discovery process of finding what parts go with what parts to actually make the very simple chain. Yeah, it's obviously two pieces of software with a with the audio sync effectively operating almost like a pipe in your bash script, right? But with audio, right? And yeah, once you know how it works, obviously you can see there, that would be more or less the time it would take to install it from scratch. It took longer to actually update the VM than anything else. So obviously, I just produced a few clones after I did that, and so it's really quite simple. And if you actually wanted to implement that as yourself, well, that's how long it takes. Well, probably about the same, say on Ubuntu, Mint, or whatever else. It's obviously using apt-gets rather than yums or RPMs, but other than that, it's basically the same thing. I'll just stop the share there.
Okay, I've got a few questions. What did you use for an antenna on the Raspberry Pi?
Is that the antenna on the transmitter, on the balloon, or on the
balloon, on the Pi, on the balloon?
Yeah, there's the one on the balloon. The transmitter is, so the antenna is just a little stick antenna you might see on a little handy. So little, how long would that be? 15 centimeter, something like that. So 6, 7, 8 inches. Nothing fantastic, just a piece of wire essentially.
Okay. In the hardware size, what RTT433 did you use?
RTL dongle. It's the one. It's actually in the picture earlier. All right.
John, I think that question's about, says RTT433. I think you, well, could who asked the question? Do you mean?
It was back.
Oh, I was just casually wondering. Like, I've been looking at this hardware before, and I was wondering if like it was a USB related 433 thing, or was it something that you custom soldered yourself?
No. It's literally the eBay special that I showed there. So you can just go out there and buy it yourself. Obviously, if the worst comes to worst, watch television. Maybe not.
John, we're not talking about the SDR. We're talking about the RTTY module.
Yeah, that's what I was wondering about.
Yeah,
the transmitting side.
Yeah, the RTTY module it's an off-the-shelf module that provides basically just two possible tones at, in this case, 670 separation, and then we actually feed it with the RS232 transmit line from the Pi, and so you feed a 1 into it, it goes at one tone, and then you feed a 0 in, it goes to the other tone. So it's actually a frequency agile single tone generator that we just switch between two tones using the RS-232.
Yeah, that one is actually an NTX2. I've just put that into the actual chat. So if you want to actually look at that, that is actually a part of the PIT board. So that's a standard part of it. So if you buy the board, you buy that module. But a lot of people who don't buy that board still use that module. And that way you're pretty much guaranteed compliance. So, and it works. So everyone basically using fairly consistent hardware. The channels might change, and that's obviously something to bear in mind when you just saw that being configured, right? But that's fairly.
One of the interesting things from your point of view, Zach, I guess you're in America, is that in the UK we're not allowed to do any amateur radio airborne. So we have to use the 433 band because that's the same band that you can use drones and well, it's called the ISM band. So that's the way we get round having radios in an airborne environment. But the interesting thing is in the States, you don't have the same restrictions. So a lot of people use a thing called APRS, which is a position locating system that you're allowed to use airborne in the States and is specifically designed for this kind of application. So if I was doing this in America, I would probably use that as a protocol rather than using RTTY.
Very cool. I didn't know that. Thank you so much.
Hey guys, did you think to do some feedback from ground to your balloon to make some action when the balloon is up, for example, like remote controlled balloon? Thank you.
Yes, indeed. So we can't communicate with it on the RTTY, but we can with the LoRa. The LoRa module is actually a two-way module. I did actually write a system where the camera pictures would be reduced to a small thumbnail, something like 100 by 100 picture, and then it would transmit that over the LoRa. And I got most of it working, but it takes so long. It takes about 10 minutes to do a 100 by 100 image, which really isn't worth getting at the end of the day. So we gave up on that. But one of the features we had in that was that you could tell it that you hadn't got one of the frames, and it would then retransmit that frame. So yes, we did do that. And more recently, John's had the idea that we could have users transmitting stuff up to the balloon to maybe say have it transmit their call sign or their name or something to try and get a bit more interaction for people using the thing. But we didn't get very far with that. But yeah, it's possible. With LoRa, it's possible, and we might do that in the future.
Yeah, I just see here. So Peter, yeah, I think you probably be able to find that in the US, and certainly the major distribution will carry it, right? But they'll always bring it across from the UK or European distribution, but they'll charge you all the extra for it. I don't think it's quite so relevant to a US implementation, and as far as you can, you've probably got a wider selection of power and boards supporting that. We're quite limited on what we're legally allowed to use, and we do like to try and keep within it. And as you can see, obviously within that well, when we're getting 50, 100 kilometers or more from that very low power board, so you can imagine how far you're going to get with maybe a watt or more, right? In the US, you are limited because you can always put as much power as you like, but of course, more power you have, the longer that will last, given the given amount of battery power. Whereas, for example, this had the Raspberry Pi camera, GPS, 2 radios, and a few other bits and pieces. Yeah, it was able to offer a couple of, 4 AA batteries. It was able to run for 5-6 hours and not really take much more than the dent out of the actual batteries. If you start putting several watts of transmitter into there, then you'll your battery time will deplete quite a bit. So it's probably good if you can actually do that with the minimum power. So think low is always the thing. I mean, not think big. You've probably actually got a better situation over there. Obviously, you've got larger distances, but normally the balloon itself wouldn't travel any larger distance. You've got less worry about it flowing into the sea. And you could probably choose a module which gives you a little bit more power and possibly a bit more choice in terms of, say, SSTV. Some people have mentioned, and a few other technologies, and I say you've got much more choice over there. We're a bit more limited, but I think even this limited solution shows you what you can actually do, so it's quite good.
It's funny, I tried element 14 and it refuses to even give me a hint if I say I'm in the US. If I search one of their international sites, I can see it. But yeah, I might have other choices. I was just curious. Thanks.
Yeah, I think there is a module, SA818, which you can get as a VHF and a UHF device, and they are somewhere between a watt and a couple of watts, depending on the exact module, and they're about $7 or $8 a piece. So they're worth buying a few actually for your if you're actually going to do something like this, and that is actually that's usable in the US.
I've just published a link onto the chat. There's a guy doing quite a few things, but he's got some stuff there about APRS in use in the States, and also he's got Arduino stuff in there. So for those who are interested in those 2 areas, that website at a first look seemed like he's done quite a lot of it for you.
This is Roger. For those who are interested in chat content, John is going to give me a copy of the chat, and we will post that on our website later. So if you lose a link, you'll be there.
Brilliant.
I think we'll be updating this onto our channel as well. So the SLUG website will have more details and a bit more of an instructional of various parts and how we've used them. Not necessarily how they're appropriate in the US, but gives you the idea of where to go and what to do. I think also Heather's got was it myorangedragon.com?
Yeah.
Yeah, so
it doesn't have to be the US. I just looked at my normal suppliers to see what they had, and nothing came up. So
yeah, Radiometrics is a UK supplier, but they are about. It's just not instantaneously obvious. All right. If nothing else, of course, we can send you one in the post. And but yeah, it's about the right size. It's a good compromise, Peter. All right. You just don't want too much power, really.
That's the kind of. I mean, this is why I really appreciate you guys talk, because the things you guys thought about to make this work is. I mean, I think it's a great talk. It's food for thought, that's for sure. Thanks.
Yeah. I mean, obviously, a couple of devices are a bit redundant. I mean, we didn't really use the LoRa. We'd like to use the LoRa, and I think that's obviously a part of. I know I've run out of various descriptions. The sheepdog. It's not the puppy. Is it the puppy? I never quite remember. But the argy. But it's puppy, dog, shippered, whatever. But whereas if you don't know where the balloon is, you don't want to have a pointable antenna because you don't know where to point it. Right. So a normal conventional vertical antenna, although it's very generic and obviously the reception is more or less omnidirectional, right? That's good because you will get a signal even if it's really poor, but the actual signal quality is also very poor, right? Potentially, right? Whereas a pointable Yagi sitting on a tripod means you get a much better link, and as such you can support things like LoRa. So although they're good, to have a reasonable data rate, you need a better link. So going forward, you might be able, we do have an intent to have another launch with slightly different electronics, so we may have another go with LoRa. And it's a compromise. As I say, it's speed, power, and actual distance. You know, you've got that triangle. You can have two of the three, as it were. Right, but you have to make your compromise. Although the actual LoRa device will allow you to program that compromise, and it's quite good.
Sorry, John.
Sorry, Peter, I'll be going to the UK in December, so I can bring.
I'm pretty sure I can source it. And another thing is there may be other rules here that restricts us from doing stuff that is allowing what you're allowed to do. I mean, just me trying to fly a quad anywhere, even with permissions that I have, is getting quite troublesome. So, yeah, there's lots of.
The good thing about a balloon is that within a few minutes, it's somewhat above where the jets are flying anyway. Right.
Doesn't matter. They get panically. We have Zach, if he's still on. I mean, I think he's been on talking about the trouble he's had just flying a kite with a camera in DC. Yep.
Maybe DC isn't the place to fly
your
balloon.
This area is not.
Yeah, the DC special flight rules areas are very restrictive. The only way that you can have something legally up and flying is kites. So like on the plus side, like I did use a Raspberry Pi to fly some kites around, and I was able to do some pretty cool, take some pretty cool aerial photos that way. But like it's still it's a hard problem.
Yeah, the last thing you really want is for your payload to drop on the south lawn of the White House. I think that might cause some minor issues.
Or just try the Conquest and see what happens. Yep.
Or in the courtyard of the Pentagon. You know, there's lots of places around here. So if I were to do something like this, I would take a week-long trip to somewhere like Arizona where nobody.
I don't know if you can see the screen share I just did.
Nope, it's all black.
It's a black screen.
There we go.
You got it now?
Yep.
There's a few there.
So that's that live tracking program. So there's what 1, 2, 3, 4. There must be 25 balloons in the air over the US at the moment.
But it's a very old way of getting atmospheric information, right? So it's just how do you get to this point as a non-professional, non-government person to be allowed to do that?
Well, all of those ones that I just showed you are not professionals, or are they? No, some of those are. Yeah, sorry, some of those.
The majority are they? They're schools or amateurs in some respect.
That picture includes the radio sons, John. So
they're not. I don't think it's all the radio sons. It's a mixture there.
But they're so. But you can do it. It's. I'm sure there's plenty of places in the US that can.
It's just knowing those rules and what you allow them to transmit. I may not be, or vice versa, right? So anyway, that's why I'm saying to John that it may not be the best idea just grabbing whatever is allowable and working in the UK. But
Yeah.
Yes, definitely definitely take care, because, as you say, the authorities do get quite stringent on that sort of thing.
Yes. We wouldn't want.
Yeah,
to
especially if you have clearances and that type of stuff.
That's true. Absolutely.
For the US, best place to look is Part 97 of the FCC. They usually keep that pretty well updated.
Yeah, I've just counted 16 non-commercial flights in the US at the moment. So, yeah. Oh, well,
Very cool.
anybody else want to ask any questions?
When is your next flight?
Well, the answer to that was going to be March of this year. But then, yes, something happened, as you may have now gathered.
Gee, I wonder what
so-
that would be.
I think we're optimistic that yes, we should be able to get something going in the not too distant future. Obviously, it's a problem if it lands on someone's garden or something like that, because we wouldn't want to go into onto their property anymore. But yeah.
You see the window open there,
Yes.
John?
Yeah, we do.
This is the VM which I made earlier. All right. So really, although obviously the VMs can be quite powerful, right? They're not really known for doing any real-time work, and this seems to work very well. I'll pass through the USB dongle from the host, and you can see the software working here. All right, and that's as we speak. So it is fresh data. All right, and you can actually see this is the LoRa. Can you see the to the right? Well, to the right and the left, but really it's to the right of the main data. A bit further up in frequency is the LoRa transmitter itself. So it's transmitting, but I don't think it's saying much sensible. I don't know where we left that, Heather. All right, but you can actually see it there. So that's quite just a little thing. You can run these in the background is the point. So once you've made your little pet, you can run this in the background, and you don't need to affect your main computer in any way while you're doing it. And so if you actually were talking about receiving things from satellites or SSTV or another radio gadgetry, you can do all that from here in the same manner. All right, it's just that whatever you attach to that monitor is the current actual fact. You can run several things at the same time. So if you're not worried, you can just leave them all running, listening to the same monitoring output, and they'll just come out with their images and data as they do. I'll just switch that off. I think we have another question, don't we, John, on the chat from Brandon?
Yeah, looking at balloon launches around the mid-Atlantic, they seem to be blown out to the ocean. So probably a good idea to go well inland from DC. Yeah, there are.
Yes, I'd agree with that. Yes, you really, really want to be sure of getting it back, even though it's only sort of $100 worth of kit. It's the amount of time and effort you put into it that you really want to get it back so you can do it again.
I think you're also finding there that the some of those balloons are actually designed to go around, so they will be of a different design where they will transmit very, very infrequently and quite often have a little teeny weeny solar cell and a what they call ultra capacitor, and then they will transmit periodically dependent on the sun, and whisper, the so-called whisper network will pick them up, and that's a very low power level. All right, and they're actually quite though they're actually going quite a bit further than these balloons. They're actually only probably a third or a quarter the size using a few mylar metallized balloons, and they'll just keep going and going. Having said that, of course, I'm sure there's plenty of normal weather balloons going out there, but they're not meant to. They're probably unlikely to actually last any journey.
I want to make sure I heard that figure right. Heather, you said the one flight from takeoff to where it landed was 200 miles? Like,
Yeah.
literally, that's how far you drove to go get it, roughly 4 hours, give or take?
Yeah.
Was that right?
Yeah, that's it exactly.
So they drove 600 miles.
Yeah, we drove quite a lot longer. Yes, yes, but yeah, that's about it. It went from here, which as you saw is sort of up near the Welsh border, and it landed just this side of London.
Unlike Mr. Kennedy, my geography is kind of rough in your neck of the woods, so I'll take your word for it.
Fair enough. Yeah.
400 miles would clicked with me.
200-ish miles. Yeah, I think that's about right. Is that
Yeah,
right, John?
Yeah, that's Heathrow. So in actual fact, it's quite a bit less as the crow flies, but not necessarily as the balloon flew. Yes. Right. So the balloon actually went. I think it even started off going north, which was quite odd, and then come back down south. You've got no real control of once you've let go of that balloon, it's going where it's going, and that went round. It did lots of gyrations, so probably the overall journey could easily been 200 miles, and of course we're chasing it on the road, so we're not going at a direct route by any stretch. And
But the jet streams you're going to are pretty powerful too, right? So
I mean,
no wonder it moves.
Oh god, yeah, good. Yeah, I think was it about 40 meters per second? I think, Heather, we got it up to, or was it a bit higher than that, maybe? Right.
Yes.
And if it's stuck in the jet stream or a bit longer, it would have been a lot quicker. And I think the first one, we were quite worried that it was going to end up in France. But the balloon gave up, and that we didn't have to go to Paris to pick it up, so I was quite relieved, really. Although it did land somewhere. So a lot of people said, well, why did you release the balloon when you was going to go to Heathrow? But we don't know these things, so they do what they do once they're released.
Yep. So,
and John, that link Heather sent for the US side, the circuit boards they are selling and the components, it's the same radio. So I guess I'll have to figure that one out.
Oh, yeah, well, we could certainly ship supplies to you, and that's not a problem.
No, I was just curious to what they were using. That was it, and that's what's on their board.
Yeah. I think, as I say, you think you want to have more power, but then you think about it again, and you realise that even the most efficient of those transmitters are at best 50% efficient. So you have more power, then you have less battery life. So in actual fact, you might cut your own throat in terms of that. If you've got a 4, 5, 6, however many hour journey, right? And even though you got we use some the lithium energizers, ones with a 20-year life and all this business. All right, so they are indeed about the best battery for the job, but I don't know how long they will last, but certainly they won't last as long when you're pulling a few amps out of them, all right, for your big powerful transmitter. So small is indeed beautiful in this instance. So we're quite glad we cut our cloth there.
And if for people also interested in more in depth in this, there is a UK based company called Sent into Space, and they do roughly the same thing but on a slightly larger scale, and they'll get up to 120,000 kilometer height, and they have a camera as part of their payload. So if you look on YouTube for Sent into Space, they have some really cool videos of what they've done. They're more
about 120,000 feet, where ours was about 90.
Yeah.
So yeah,
they're literally right on they're 99.9% out of the close to space. They call it near space. And they have a website too, and they're commercial, so they're probably not, it's not a hobby thing for them. So yeah, if you want to see some really cool videos.
Hmm.
Yep.
Any more question?
It's just one dumb comment. Some of my stupid YouTube that I do to just watch to have a laugh. One of those for people who are claiming the Earth was flat because they sent up a balloon with a camera where the lens effect did the opposite, right? So it made it look flat instead of making it look curved. But of course,
Yeah, well, there is a curve, but the curve is less than the curve in the barrel distortion in the lenses. So,
yep.
Depending on whether the Earth is in the top or the bottom half of the lens.
Yeah, that was the funny part because they had edited the raw video, so it only showed those part way in the middle where it looked flat. But yeah, it was funny to watch that and think. I wonder if they use one of these projects to get up there. But
one thing you do have to bear in mind is, as I said, at the 25-30 kilometers up that we get, you will not see enough curve to know that it's there.
Mm-hmm.
If you look at it as in relative to how high how far off the globe you actually are, you're really not very far off at all. The pictures that these guys, the sent into space guys, they're going probably 3 times the height that we're going, and they're just starting to see the curve there.
Everyone has a lens effect anyway when you look out. Even your eyes has one, so you got to be careful.
Exactly. Yeah.
I have been
I'm
asked.
pretty sure the.
Go ahead, Heather.
I was going to say I'm pretty sure the Earth is curved.
Pretty sure
might,
only. Okay.
It might be. But Roger has asked, since people are starting to drop off, if everyone can turn on their camera so we can take a group picture of everyone just to put on with our to put onto our site.
And thanks for presenting. This was a good presentation, even though I was only on for like half of it.
Zach, move your camera down a little bit. It's chopping off your head. Everybody look at the camera and smile. Chuba, Charlie, Terrence, I can't see you.
And
we're going to take a picture here. It takes a minute. So smile. Is everybody smiling? You're done.
Right.
Beautiful. Choba, Jim, and Charlie are not there.
Charlie just came back. No.
I finally found the control just after you said you took the picture.
I'll do it again. Oh, no, I'll do it again. It just takes a minute.
Do it again, and then for those who dropped off. All right, go back on.
Okay, here it goes. Smile. Look at the camera. Look at the camera. There, you're done. That's it, Charlie. Thanks. Done.
All right.
Oh, great topic. Very interesting.
Yeah, that was very
Yes.
Yet another thing, it's just as awkward in the physical world as it is in the or as it is in the Zoom world. Group photos, that is.
Heather, I was glad to see it was dogs and not cats.
Fair enough.
We're wasting.
Well, the balloon is actually quite difficult to actually herd, so yeah, maybe we should have had cats in there.
No. It's a waste of the cable going from Great Britain to the United States to put all those cat photons out there.
I will make my own personal judgments later.
So you're a cat man, Zach.
Yes, I am. we have a bunch. I'll see if I can find any that are hanging out at the moment.
I can just see Zach tying one of them to his kite,
Don,
giving them
you're on mute.
a good look from the above.
All right, guys, I am going to stop the recording now since we've gotten well off target, off topic.
I see some eggs on screen.
Before I go, I will thank Heather and John for the talk. It was really cool. I enjoyed the hell out of it. And if anyone has any questions, you can email me and I can pass them on to either John or Heather later on down the line. And yeah, so thank you again. And hopefully there's a cat. Heard that cat, Zach.
Take it, take it.
So
Yeah.
so we're gonna
He's
go
a
ahead.
loud one.